Section 8.3 is logarithm and logarithmic functions. If you look at the graph of y equals 2 to the x power, which is in black, the inverse of y to the 2x power is in red, and that's what the graph of the inverse looks like. The inverse of y equals b to the x is x equals b to the y power. The variable of y is called the logarithm of x. This is usually written as y equals log base b of x, or another way we could write it is log base b of x is equal to y. I kind of like the log being on the left side. The way we read this is log base b of x. So your base is a subscript. So it's log base b. This is your base of x is equal to y. Log base 2 of 8 is what? Well, 2 to what number gives you 8? 2 to the third power is 8. So log base 2 of 8 is 3. What we're going to do, what I forgot to mention a minute ago, is this. We have to convert logarithmic form to exponential form. So to put it in exponential form, your base is b, your exponent is y is equal to x. So you're going to have to memorize log base b of x is equal to y. That's log form. To put it in exponential form, it's b to the y power is equal to x. So I would put that on your index card. Example 1, change to exponential form. Okay, I'm going to write my little formula again up here. Log base b of x is equal to y. That's b to the y power is equal to x. So to put log base 3 of 729 is equal to 6, we're going to practice putting it in exponential form. That's 3 to the 6th power is 729. Now pause this for a minute, get your calculator out, and put in 3 to the 6th power, and you better get 729. Example B, log base 2 of 8 is equal to 3. That's 2 to the 3rd power is equal to 8. And example C, log base 4 of 16 is equal to 2. That's 4 to the 2nd power is equal to 16. And example D, log base 4 of 1 over 256 is equal to negative 4. So that's 4 to the negative 4 power is equal to 1 over 256. Example 2, write each equation in logarithmic form. Okay, let's write our formula again. Log base b of x is equal to y. That's b to the y power is equal to x. So here we're going to go exponential to log. So my base is 4. So that's log base 4 of 2 as I was saying, log base 4 of 2 is equal to 1/2. Example B, 15 to the 3rd power is 335. So that's log, my base is 15, so log base 15 of 3,375 is 3. So look, these get reversed. That helps. Example 2, write each equation in logarithmic form. So once again, it's log base 4 of 64 is equal to 3. And example D, 125 to the 1/3 power is 5. That's log base 125 of 5 is equal to 1/3. Turn off the, pause the recorder and you try to do these 3 problems. Okay, so if you want to think of that as an x right here. Whoops. 4 to what power gives you 16? 4 to the second power gives you 16, so log base 4 of 16 is equal to 2. The second one, 5 to what power gives you 5? 5 to the 1 power, so log base 5 of 5 is 1. And log base 9 of 1, so that's 9 to what power gives you 1? And anything to the 0 power is 1, so log base 9 of 1 is 0. Log of 2/3 to the 4/9 is what? So if you want to replace it, put an x there, and then go to this side and put an exponential form. That's 2 over 3 to the x power is equal to 4/9. So if I squared 2/3, I'd get 4/9. So my answer is 2. So 2/3 to what power gives you 9 over 4? Well, if you notice, I've got a square 3 gives you 9, but that's in the numerator. So if I put a -2 right here, I'd have to flip that to be positive 3/2 and then square it. So log base 2/3 of 9/4 is -2. Seven to what power gives you 343? If you look on your index card, it might help you. If not, 7, so use your calculator. 7 to squared is 49. 7 to the 3rd power is 343. So log base 7 of 343 is 3. 16 to what power gives you 4? Well, I've got to convert that 16 to 4 squared, and then that's equal to 4. This is a review of the other day when we had to have our common bases. So our base right here is, our exponent to the 4th power is 1. So once you have your bases equal, you put your exponents equal to each other. So 2x is equal to 1, or x is equal to 1/2. Log of 1/3 to 125. Well, that's 1/3 to the x power is equal to 125. I've got to convert 125. First, I've got to put the 3 up top. So that's going to be 3 to the -1 power. So that's -1x is equal to 3 to what power gives you 125? I have an error. That should be a 5 right here. Oh, it's not going to work. Okay, so log 1/5 of 125 is equal to, so that's going to be a 5 right here. And that's 5 to the 3rd power. Once your bases are equal, so that's -1, x is equal to 3, so x is equal to -3. Log base 12 of 1/12 is equal to what? Well, that's 12 to the x power is equal to 1 over 12. I've got to turn that 12, move that base up top, so it's 12 to the negative 1 power. So x is equal to negative 1. Evaluate. Log base 16 of 4 is equal to, well, I'm going to right away put an x there, or you can put a y, whatever variable you want. Now, I am going to convert to exponential form. So that's 16 to the x power is equal to 4. Then it's just a review of the previous sections where you want to get a common base. I'm going to convert 16 to 4 squared and bring to the x is equal to 4. 4 to the 2x power. I don't know what I said. 16 is 4 to the 2x. And then this 4 has an exponent of 1. So once your bases are equal, you just put your exponents equal and divide, so x is equal to 1/2. Okay, log base 3 of 81 is equal to x. In your book, it doesn't even have the equals sign. It just has log base 3 of 81. I need you to put the equal x. It's so much easier. And then put that in exponential form. That's 3 to the x power is equal to 81. We've got to get our common bases, so that's 3 to the x is equal to 3 to the what power gives you 81? 4. So x is equal to 4. Log base b of 1/2 of 256 is equal to x. That's 1/2 to the x power is equal to 256. Okay, two things. I've got to get this 2 up top, so that's going to be 2 to the negative 1 power. And then I bring the x. And then I've got to convert 2. 2 to some power is 256. So pause the computer, the video, and get your calculator, and you try to figure out 2 to what power gives you 256. Okay, so 2 to the 8th is 256. And then we just put, I'm going to go over here. That's negative 1x is equal to 8 divided by negative 1, so x is equal to negative 8. Example D, log base 2 of 1/8 is equal to x. That's 2 to the x power is equal to 1 over 8. I've got to convert 1 over 8. That's 2 to the 3rd, but I've got to move it up top. So that's 2 to the x power is equal to 2 to the negative 3 power. So x is equal to negative 3. Example 4, log base 3 of 9x is equal to 4. Put that in exponential form. That's 3 to the 4th power is equal to 9x. Okay, so that's 3 to the 4th power. I've got to convert this 9 to have an exponent. Okay, that doesn't work by doing that, or putting the 3 to have an exponent of the 9 to put 3 because of that x. So that does not work. But what does work? Can I calculate 3 to the 4th power? Oh yeah, 3 to the 4th power is 81 is equal to 9x. X is not in the exponent. It is in the whole number. So I don't need to try to do exponential, so I'm just going to divide by 9. I was making it too difficult. 81 divided by 9 is equal to x. So that is your answer. And that is all for section 8.3. Here's your assignment. Make sure you go and check your odd answers in the back of the book.